In this video, we're going to talk about how we can multiply complex numbers together and how to simplify imaginary numbers with exponents greater than 1. So in this slide, we're going to explore that imaginary I a little bit more and talk about how we can simplify values with I that contain an exponent other than 1. So what you should know straight off the bat is just plain I can't be simplified any further than it already is. But you also should know that I is known as the square root of -1. So that's just the definition of I that you should know, and we're going to use that to figure out what the rest of these exponents actually mean. So since I is the square root of -1, that means I squared, so if we were to square both sides of this equation here, I squared is equal to a -1. So what you should be able to do anytime you see an I squared from here on out is rewrite that I squared as just -1. They are interchangeable, they are the exact same thing. Now, I to the third power, while it looks like it might be tricky, what I like to do with all of these is break them up and say, well, I know what I squared is, and I to the third can be represented as I squared times I. Well, I know that I squared is -1, so this is really -1 times I. So I cubed is really equal to -I. So notice here that we were able to simplify this down a little bit. It's no longer I cubed, but I cubed can be rewritten as -I. So here we know so far that I squared can be rewritten as -1, and I cubed can be rewritten as -I. Now I to the fourth, we're going to apply this same idea of I squared. We know I to the fourth can be rewritten as I squared times I squared. Now I squared is equal to -1, so this is really -1 times -1. So I to the power of 4 is really equal to 1. So notice that all of these get a lot simpler if we just apply what we know about this I squared value. So now if we continue, let's take a look at I to the power of 5. And while I can rewrite I to the power of 5 using I squared, I now have an I to the fourth I can deal with here. So let's break this up into I to the power of 4 times I. Well, I know I to the power of 4 is 1, so this is really 1 times I, which is just I. And then lastly, if I take a look at that final one there, I have I to the power of 6. I'm going to break that one up into I to the power of 4 times I to the power of 2. Well, I to the power of 4 is 1 times I to the power of 2 is -1. So this is really equal to -1. So hopefully what you're noticing here is we're kind of going in a circle. I is just plain I squared is -1, I to the third is -I to the fourth is 1, and then when we get to I to the fifth, we go back to I, which was first, and I to the sixth is -1. And then if we continued this pattern, I to the seventh would be -I, and I to the eighth would be 1. And so we can continue that all the way through. So really, even if we had something like I to the power of 362, we could simplify it to one of these 4 values. So what we learned on the previous slide is that I to a power kind of goes in a circular way. So I to the power of 1 was I to the power of 2 was -1, I to the power of 3 was -I, and I to the power of 4 was equal to 1. And what you hopefully also noticed is that when we had I to the power of 8, that was 1. And then hopefully you can make the prediction that I to the power of 12 is also equal to 1, because we're going around every 4. And what you should notice is that everything that has a power that is divisible by 4 is equal to 1. So what that tells us is that I to the power of 48, if we were to keep going with that pattern of 4, I to the power of 48 is equal to 1. So what we can do here with this I to the power of 49 is we can break this up into I to the power of 48, which is divisible by 4, and I to the power of 1. And then because I to the power of 48 is equal to 1, this becomes 1 times I to the power of 1, which is just I. So I to the power of 49 eventually simplifies to just a singular I. Now if we look at I to the power of 80, what I notice is that 80 is divisible by 4. And because I to the power of 4 is 1 and then 8, 12, if we keep going with that pattern, because 80 is divisible by 4, this is just going to equal a positive 1. Then if we look at the example down below, we have 5 times I to the power of 34. Remember, I to any power that is divisible by 4 is just 1. So this becomes I to the power of 32, that is divisible by 4, I know is equal to 1. So I can really rewrite this problem as 5 times I to the power of 32 times I to the power of 2. So that becomes 5 times, well, I to the power of 32 is 1, times I squared, I know can be rewritten as negative 1. So I have 5 times 1 times negative 1, which becomes a negative 5. And then finally, if I look at that last example there, again, I know that I to any power that is divisible by 4 is going to be 1. So I know I to the power of 20 is going to give me 1. So I can rewrite this as 7 I to the power of 20, and then it's I to the power of 3, which here I know is 7 times 1. And if you know I to the power of 3 is negative I, that's great, you can go with that, or you can split this up even further to be I squared times I. So I have 7 times 1, which is 7, times I squared, which is negative 1, times I. So this becomes a negative 7I. So now that we have a solid understanding of how we can simplify i's with an exponent other than 1, we're going to try to simplify these expressions that are on the screen here. So you'll notice that we have a number of complex numbers that are being added or subtracted, and our goal is to simplify them so that they are fully simplified in standard form, where all of the real and complex parts are combined, and where those exponents of I all have an I value with an exponent of 1. So to start, let's rewrite this without parentheses. So I'm going to go through and utilize keep, change where appropriate, put in that negative 1 there. And here I'm just going to distribute this negative 1, distribute this 2, and remember there's a positive 1 out in front here. So this would become 5 plus I cubed plus negative 7 plus 4I to the 7th, then that's plus negative 6 and plus negative 2I to the 20th. Okay. So I have all of that written out. Now I'm going to combine together my real parts to start. So I know that 5, negative 7, and negative 6, well, 5 and negative 7 become negative 2 and negative 6 combined to be a negative 8. So I have negative 8 plus I cubed plus 4I to the 7th plus negative 2I to the 20th. So I have to simplify each one of these. Now, what I do know is that I cubed is really just I squared times I, and I squared is a negative 1. So this is negative 1 times I, which is just a negative I. So I can rewrite that I cubed as negative I. I also know here I have 4 times I to the 7th. Well, that's just a 4 times, I'm going to break that I to the 7th up into I to the 4th times, I'm going to do I squared times I. And so that becomes 4 times 1 times negative 1 times I, which is going to be 4 times 1 times negative 1. That's negative 4I. And then I'm going to take this next piece here. Well, that's negative 2 and I to the 20th. 20 is divisible by 4. So I to the 20th is really times 1. So that's going to be a plus negative 2 down here. So notice that I simplified each of these, and what I ended up with here are 2 real parts that need to be combined. So here I have a negative 10 and 2 complex parts that combined to be a negative 5I. So using what I know about simplifying, I was able to take 3 complex numbers added together here and find what that complex number would be when they're all combined with all of those I exponents simplified. So now here, let's take a look at number 2. So let's distribute that -5 to start. So here I have I to the power of 21 plus -15 plus 20I to the 18th minus 6I to the 15th. Then I'm going to use keep change here just so I don't make a sign error later on. So from here, I need to simplify all of these I exponents. So this one I can rewrite as I to the power of 20 times I to the power of 1. I to the power of 20 is divisible by 4, so that's just 1 times I, which becomes I. That -15 is just going to stay -15. That can't simplify further. Then I have 20 times I to the 18th. Well, I know that this becomes 20 times I to the 16th times I squared. So that's 20 times I to the 16th is divisible by 4, so that's 1, and I squared is -1. So that becomes 20 times 1 times -1, which is a -20. And then this last piece here, this becomes -6, and then I can do I to the 12th, and then I'm going to do I to the 3rd here. So this becomes -6 times 1 times, I know I to the 3rd can be rewritten as I squared and I, which becomes a negative I value. So I have -6 times 1, which is -6, times that negative I. So I have a -6 times a negative I, which is a positive 6I. Then to end here, I combined the like parts together. So I have my real numbers first. Those become -35 plus the imaginary parts, which become plus 7I. So now we're going to take what we know and we're going to multiply complex numbers together and then simplify them. So what you see on your screen are two complex numbers, 6 plus 4I and 5 minus 3I. And we're going to multiply these values together. Now remember, when we multiplied two items that look like this, so we have two items in the first parenthesis and two items in the second, we're going to take each item in the first parenthesis and multiply it by each item in the second. So we have 6 times 5, which is 30. 6 times -3I, which is -18I. And then 4I times 5, which is a positive 20I. And then 4I times a -3I, which is -12I squared. Now I'm going to use keep change here so I don't make any sign errors. But I noticed that not all of these with the i's are simplified. I need them all to have i's with an exponent of 1. So I'm going to simplify this a little bit further here. I know that I squared is really -1, so this becomes -12 times -1, which becomes a positive 12. So we have the rest of these all simplified. Notice that those I values should only have an exponent of 1. That is it. And once we have all of our I values with an exponent of 1, we can combine together our real parts and then our imaginary parts. So here I have 30 and 12, which become 42. And then -18I and 20I, which become a positive 2I. So let's multiply two more of these together. So in this first one, I can see that I'm multiplying -5I times -7 plus 9I. And because there's just one item here, I'm going to distribute and simplify. So this becomes -5I times -7. It becomes a positive 35I. And then -5I times 9I becomes a negative 45I squared. So what we need to do here is we need to simplify this further because all of our I values need to be simplified until they have an exponent of 1. So I'm going to utilize keep change here, and then I'm going to simplify what I know using those I properties we talked about earlier. So this is -45 times I squared. Well, I squared can be rewritten as a -1. So -45 times -1 gives us at the end 35I plus -45 times -1 is a positive 45. Now if we look over at the second example here, we can see we have -4 minus 11I squared. And as tempting as it is to just square both items inside of those parentheses, we can't do that. This really is -4 minus 11I times itself. So just take the time to write that out so you don't make a mistake. Then from here, I'm going to utilize keep, change, change. And then I'm going to multiply everything in the first parenthesis times everything in the second. I'm utilizing the distributive property. So negative 4 times negative 4 is 16. Negative 4 times a negative 11i is a positive 44i. Negative 11i times negative 4 is a positive 44i. And negative 11i times a negative 11i is a positive 121i squared. Now, while I'm almost ready to simplify, I'm not quite there because I need to make sure all of my I values have an exponent of 1. So this here becomes 121 times I squared. And remember, I squared can be rewritten as a negative 1. So this becomes a negative 121. And then we have the rest of that expression that we're going to combine that with. So now that we have these fully simplified with I values that have exponents of 1 only, we can combine our real parts here, and 16 and negative 121 become negative 105, plus our imaginary parts, which combine to be 88i.